Moving into a new area of the course, we're going to be moving into what are called rational expressions. Rational expressions essentially are fractions, and we're going to start off with some basic rational expressions or fractions. What we're going to need to do now is simplify these fractions, or we're going to call them rational expressions. We'll start off with what are called restrictions on rational expressions, and we will have restrictions when the denominator is equal to 0. If you recall, you should remember this, that if you say like 4 over 0, 4 divided by 0, that's 4 divided by 0, that is undefined. You cannot divide by 0. 4 divided by 1 is 4, but 4 divided by 0 is undefined. Now you can do 0 divided by 4, and that gives you 0. But 4 divided by 0, there is no answer. It's just undefined. So we're just going to put UND, and that means undefined. So whenever the denominator has is 0, not has a 0 in it, but is 0, the value is 0, that's when we have an undefined fraction. So that's what this whole first section is about here. Here's a given fraction, 5 over x minus 2. Find all values of x for which the rational expression is undefined. These are also known as restrictions. I have it right here. So what would x have to be? What would the x value be so that this denominator is undefined? Well, see how it's x minus 2? If x is 2, then that gives us 2 minus 2, which is 0. So that means that we'd have a 0 in the denominator. Our denominator would be 0. So the answer to this question is 2. The value 2 would make this fraction undefined. It would be a restriction. So the way we're going to write that is we're going to say x cannot equal 2. X cannot equal 2 for this fraction, because if it does, the fraction has no meaning at all. It's undefined, because 2 minus 2 is 0. We'd have a 0 in the denominator. Same thing here. Now 3x minus 24, it turns out that x would have to be 8, because 3 times 8 minus 24. 3x, and another way to do this is you could just set the denominator equal to 0. 3x minus 24 equals 0. You can add 24. 3x equals 24, and then divide by 3, and you'd get 8. So x cannot equal 8. You put an equal sign with a slash through it. X cannot equal 8. For this one, again, no, we don't even care about the numerator. Don't even care about it. It doesn't matter. The numerator has no meaning. It doesn't for undefined. We only care about the denominator. For C, it's going to be easier to factor, because it's difficult. We got x squared, we got x here. What number squared minus 6 times a number plus 8 gives me 0? That's tricky. But if you just factor it, x minus 4, x minus 2, that's what this is. Okay, well, it's x minus 4, x minus 2. So if x is 4, I'll get a 0. And if x is 2, I'll get a 0. So x cannot equal 4, and x cannot equal 2. Those are my restrictions. And then for part D, that's x times x minus 7. So I have an x, therefore x cannot equal 0. And I have x minus 7, so x cannot equal 7. So those are my restrictions. I have a restriction of 2, 8, 4 and 2, 0 and 7. These are the numbers that will make the denominator undefined. It will make the denominator 0. That will make the fraction undefined. All right, now, reducing to 1. That's what reducing fractions or simplifying rational expressions is all about. It's all about reducing to 1. You may have done stuff like this, like 15 over 20. I know you've reduced that before. Sometime in your mathematics career, you have reduced 15 over 20. But you may have used the word cancel. We're going to get that word right out of our vocabulary. We're not going to be using the word cancel anymore. We're going to be using the word reduce, and we're going to say reduce to 1, because that's how you simplify fractions, is by reducing to 1. Show you how it works. And we're doing a very basic example here. Now, you may know that 15 over 20 is 3/4. You may be able to do that in your head. But I want to show you why it's 3/4. It's all about factors. It's all about factors, guys. 15 is 3 times 5. That's the factors of 15. 20 is 4 times 5. 4 times 5. See that? So we factored 15, we factored 20, and now we have this 5 over 5, which we don't say cancel, reduces to 1. Because 5 divided by 5 is 1. Now, I know it seems easy. Mr. Venture, I knew 3/4 in my head. Yeah, you did, because it was an easy one, 15 over 20. But what about when we get something like that? Okay, so that's why we really want to be proper and go through the process the right way. 6x over 10x. Okay, well, 6x over 10x, that is going to be 2 times 3 times x over 2 times 5 times x. See, that's 6 and 10. And then the x just kind of comes along for the ride. It's all multiplication. Notice how it's all multiplication on top and all on the bottom. 2 over 2 is 1. X over x is 1. Times 1 times 1. I'm left with 3 times 1, which is just 3, over 5. 3/5. Okay? That's how we're going to proceed here. If you don't skip steps and don't take shortcuts, it's going to be a lot easier for you. X squared minus 36. Let's factor that. X plus 6, x minus 6. And I'm going to go fast on this video with the factors, guys. You might want to pause and try these by yourself to get a little practice with factoring. But I'm to the point where we should know this factoring list. Factoring should be like this by now. Okay? All right, now we don't have common monomial factors, but we have binomials that reduce to 1. X plus 6 divided by x plus 6. X plus 6 over x plus 6, that is 1. So I take my x plus 6's, and that reduces to 1. And I'm left with just x minus 6 over 4. There we go. And here, 2x, you should pause the video and try factoring this one. The bottom's a little easier. 2x plus 3, 2x minus 3. That kind of gives me a hint. There's probably going to be a 2x something 3 over here, right? I'm just guessing. So I'm going to try to put a 4 there. And then 8. Oh, I need minus minus in order to get a negative 11 and a positive 12. So there it is. That works. And I have, look at this, 2x minus 3, 2x minus 3. That reduces to 1. So I'm left with x minus 4 over 2x plus 3. Now, you don't have to put those in parentheses, but let's get in the habit of doing that. Let's put binomials in parentheses, keep them in parentheses, because it's going to help us determine what can be reduced and what cannot be reduced further. Now, reducing to negative 1. This is a special case where we can actually factor a negative 1, and then it helps us reduce to 1. And then the reducing to negative 1 is kind of a shortcut. So I'm going to show you A and B. I'm going to show you it the long way, and then we'll get a shortcut. X minus 5 is just x minus 5. We're going to keep that the way it is. Now, 5 minus x is not the exact same as the thing as x minus 5, but what you can do is factor out a negative 1. Now, factoring out a negative 1, what that does is it just changes the sign, basically, of everything in the binomial. So I can write this, I can rewrite this as negative 1 times x minus 5. Now let's see why that works. Well, if I distribute that negative 1, it's negative 1 times x, which is negative x, which is what I have here. And then negative 1 times negative 5 is positive 5, which is what I have here. So that's essentially what I did is I took the negative 1 out and made it x minus 5 on the inside. And that is the exact same thing as 5 minus x. So now, why did I do that? Because x minus 5 over x minus 5 is just 1. So I'm left with 1 over negative 1, which is just negative 1. So I actually reduced down to negative 1. 2x minus 3, I'm going to keep that the same. But look at this one. See how it looks backwards? If it's backwards but a minus, you could do the negative 1 factor. Negative 1 times 2x minus 3. It's the exact same as part A. And then, of course, I have 2x minus 3 over 2x minus 3, which is 1. And I have 1 over negative 1, which is negative 1. Now I'm going to show you how to use this and apply it to more complex fractions here. So I have this one, I have x plus 4 over x minus 4. So I have x plus 4 over x minus 4. And then here I have 3 times 4 minus x. That's my factors. 3 times 4 minus x. Now, at first glance, it looks like nothing reduces. I don't have a 1 anywhere. However, I have an x minus 4 over a 4 minus x. That's exactly the same, except it's switched around with a negative. So what we can now say, based on what we learned in part A and B, is that reduces to negative 1. So you can cancel it, you can reduce it and write a negative 1. We don't use the word cancel. It reduces to negative 1. So I'm going to be left with negative 1 times x plus 4 over 3. And you don't have to write the 1. You could just say negative parentheses x plus 4 over 3. That's going to be your final answer. All right, here we got a little tough factoring there. 2x and x. All right, and on the bottom I have 5 plus 2x and 5 minus 2x. I did the bottom first to help me with the top because I see 2x's with 5, so it's probably going to be a 5 there. It doesn't have to be, but it's probably going to be with a 4 there. So looks like we need a positive here, we need a negative here. So there we go. I have 2x minus 5 and 5 minus 2x, and that's going to reduce down to negative 1. So I have negative x plus 4 over 5 plus 2x. All right, in these examples, under example 4 here, we're going to be simplifying these rational expressions using our factors. Again, getting those groups of factors and then reducing to 1 or reducing to negative 1. But we're also going to be including our restrictions. So they say here, identify the values that must be excluded to prevent division by 0. Those are your restrictions. You can't have division by 0. So we could do that right now. We're going to go through and do all our restrictions. So for n cannot be 0. N cannot be 0 because 4 times 0 would give you 0. Here, we have to factor in order to tell it. So let's factor it out. I just factor, well, we might as well factor the denominator first. So it's going to be 5x, x plus 2. So we have a 0 here. X cannot equal 0. And x cannot equal negative 2. So my restrictions are 0 and negative 2. Here I have my denominator is 4 plus y, 4 minus y, and so therefore y cannot be negative 4 and y cannot be 4. So y cannot equal negative 4 and 4. We just write it like that. Here, now this one's interesting. We never really factored one like this before, but I'll give you the factors of this one. You can kind of see why it works. Y, and then you got x squared on the end, so we have to have x and x. And then this will come from a minus x and a minus x. Now, why does that work? Because here you get a negative xy, and on over out here you also get another negative xy. Negative xy is negative 2xy. So I know some of you are like, what the heck is he just doing? But some of you I may have been able to understand that. Hopefully, if you didn't, I'll just explain it a little bit better in class tomorrow. All right, here we have, so y minus x, basically y and x can't, the restriction is that y and x cannot be the same number. So if y is 3 and x is 3, you can't, 3 minus 3 is 0. That's the only time you're going to get a 0 here. So y cannot equal x. That's going to be our restriction. Y cannot equal x. They both can't be 3, they both can't be 5. Y can be 5 and x can be 2 or whatever, but they can't be the same number. Here, and again, we only care about the denominator as far as the restrictions. All right, n cannot be 2. N cannot be 2. And then here, so for this one, you know what I'm going to do here? I'm going to factor out a negative 1. See how it's kind of backwards? Let's factor out a negative 1 right away. And we'll make it x squared. That's just going to change the signs. See that? X squared plus 2x minus 8 if I factor out a negative 1. And I'm just going to make that negative 1 there. All right, so this is going to be x plus 4x minus 2. So it looks like we can't have a negative 4. X cannot be negative 4. And x cannot be positive 2. Because if it's negative 4, I get a 0 here. If it's positive 2, I get a 0 here. All right, let's finish these up now by factoring. I could take out 2n here. It leaves us with 1 minus 4n over 4n. And I'm going to make that 4n. I'm actually going to make that 2 times 2. 2 times 2. So the n's reduced to 1, and the one set of 2's reduces to 1, leaving a 1 on top. So my final answer here will be 1 minus 4n over 2. Here I have x minus 3, x plus 2, and it looks like I have an x plus 2 over x plus 2, which is 1. So that comes out to be x minus 3 over 5x. And you can't go any further than that. Here I can take out a 3y. 3y times y plus 4. And y plus 4 over 4 plus y, that is not a negative 1. That is a positive 1. Because 4 plus y is the exact same thing as y plus 4. So right there, that is a 1. That reduces to 1. Even though they're backwards, because it's addition, it doesn't matter. It's still a 1. All right, so I get 3y over 4 minus y. This is going to be 3 times x minus y. And I have x minus y, y minus x. That reduces to negative 1. So multiply that. Negative 3 over y minus x. This is going to be 3n and n. And then 2 and 1 and minus and plus. N minus 2 over n minus 2 is 1. And that leaves us with 3n plus 1 over 2. And last one here, x minus 3, x minus 2. And that's a 1 there. And that leaves us with x minus 3 over x plus 4, and we have that negative 1 hanging out there, and we'll just bring that in front of the fraction. We could put it on top or in front of the fraction. It doesn't matter. Or you can leave it on the bottom. It really doesn't matter. But a negative on top is the same thing as a negative being on the bottom. We'll talk about that more in class. I'll see you then.